2 sessions each week, Mondays and Wednesdays, in the LSK Math Learning Center. It's on the 3rd floor of LSK, right behind White Spot. And it's basically, each session will cover different materials, so you can go to both sessions, but yeah, Wayne will tell you why you want to go.
Yeah, so essentially what you guys will get out of the sessions is we're going to focus on techniques on how to approach the class material, because they're led by people who have taken the class and have done really well, so they know how to approach homework problems, approach test problems, trying to get you guys a good way of thinking about those. And also, we'll have time to just focus on any material that came up in lecture that you guys find challenging or you guys still have questions about. And lastly, also, it's not mandatory. You guys don't have to come. It's totally volunteer. But it's a good idea, too, to get ahead or to catch up on any problems that you find a little difficult. And there's snacks provided, so that's always a good reason. And finally, there's also going to be 2 other sessions in the residence halls, although they're not scheduled yet. So we just wanted to get kind of a brief general estimate of how many people live in the residence halls here on campus. So if you can raise your hand if you live in Place Vanier. And in Totem Park. Cool. Cool. Thank you.
Thanks. Any questions about these? Don't confuse these with your mandatory Math 110 workshop that you have to go to. But these are non-mandatory.
Because I have a class that's exactly actually this class. So there's no...
There's other Math 110 sections. So there's going to be, I think that you'll get an email with a lot of different ones. But yeah.
The ones in the residence should be at a different time too. So
Yeah.
if this time doesn't work for you, there's some other ones available.
Any other questions? Please take advantage of these. Like, other students have found them very helpful. We've done them. This is the 2nd year we're doing them, but they are really helpful and they're very, I don't know. It's a good space to learn math. So, all right, thanks.
Thanks.
So maybe let me advertise a little bit more. I talked to these people and they told me a little bit about what kind of stuff you should expect there. And it's really, first of all, they deal with problems on our material content, but it will be also kind of training some of your kind of software skills, which are actually hard to train. And let me give an example of an exercise that they will do. They will get in small groups, maybe groups of 2, pairs, and one of the people in the pair will solve a problem, and then he'll have to present it to the other guy in the pair. And the job of the other guy would be, for each step, to ask why. Basically, you tell something like, okay, so this thing is equal to x plus 1 squared, which is also x squared plus 2x plus 1. And at this point, somebody will ask you why. And you'll have to say, well, actually, what I did was open the brackets. So here's how it works. X squared plus x plus another x plus 1, which is x squared plus 2x plus 1. Or maybe you'll say something like, well, and hence, something happens, and you'll be asked, well, why does it happen? And it's a really good idea to, well, know how to explain why it happens, or know how to explain why this is actually true, because you will be required in our course to write proofs. You will have questions of the type, prove that something is true, or explain why the following identity holds. And it's really a good idea to know how to explain in full sentences, in full detail, why something happens. And well, it's something that you won't have time to actually do in class. We'll have examples of me doing it in class, but for each one of you to do it, well, you won't have time. But in these workshops, you will actually have time. They're usually small, and well, they are helpful. But once again, it's not mandatory. Unlike the actual workshops, you can just use it. It's a resource you can use. You don't have to use it. Okay, another thing. So yesterday I posted the first skills module. It's due next Friday. There are 40 problems on basically high school algebra. They are short, so it shouldn't take you like hours and hours and hours. Even though it's 40 problems, they are pretty easy, and all you have to do is write down the answer. So you go to the web link find the algebra skills module posted there. You should start doing it. There are no time restrictions except the deadline on Friday. And another thing, so I plan to use speakers in this class just to, well, instead of coding using hands, I will code using one of those is APD. And please try to buy a clicker. It's the white rectangle with 5 buttons, A, B, C, D, and E. And the way it's used is I will ask you a question, write down the options for the answers, and you click on one of the options, and you'll see for each one of you who clicked what options, and then I'll have some feedback from you. So we will have a test run probably next Monday, and in the meanwhile, you will look forward and done so get the feedback. Any questions about the three announcements? The class program, the module, or the business? Yes, you have several attempts. Maybe you need to. Other questions?
Can you find them?
So if you go to our website, you'll find the link to web work. So, other questions? Okay, so let's go back to our material. Last time we discussed two ideas. One is the idea of coordinate plane. If you want to refer to the position of a point in the plane, you can do it as follows. Draw a couple of axes, call them x and y axes. Choose a scale, so choose what is 1 unit to the right, what is 1 unit up, and then just tell if you want to describe how this point is located in this plane, just tell us how many steps do you make to the right to get to the correct vertical line, and then how many steps do you make upwards. So in this case, it looks like 4,2. 4 steps to the right, 2 steps up. Then we talked about the idea of describing lines using similar technique. Well, in this case, for lines, well, a line is not just one point, it's a whole set of points. There are infinitely many points on the line, so we don't want to describe just a pair of numbers, but all possible pairs of numbers, all possible points along this line. And the most useful concept for us in discussion of these lines was the concept of slope. So let me draw some kind of line, maybe such a line. So here's a line. And what we did last time, we discussed the slope of the line. So the slope was for 1 unit of movement to the right, how many units will go up along this line? Or, in other words, if you have 2 points on the line, say these 2 points, and you know that from this point to that point, you make some amount of steps to the right and some amount of steps upwards, then the slope is just this distance divided by this distance. So we refer to it as kind of small, give it a name, usually m, being rise, how many units you go up, divided by run, how many units you go to the right. And well, the larger the slope, the steeper the line. If the slope is negative, the line goes down. So instead of going up, it goes down. Slope being 0 means the line is horizontal. So we discussed all these things. And the last thing we did last time was discuss an equation of the line. And an equation of a line wasn't even more complicated than this. So let's say we have a line, and it goes through a point x0, y0. So So you already have 1 point on the line, and you know that the slope is m. How can you find whether another point, x comma y, actually lies on this line? Well, basically you run this definition of slope once again. So if you have a point x comma y on the line, what do we know? Well, we know that the rise over run is equal to the slope. So m must be equal to what? The vertical distance is the difference in height, which is y minus y naught. So this distance is y minus y naught. The horizontal distance, the difference in x locations, in horizontal locations, is just x minus x naught. And then the slope is just y minus y naught divided by x minus x naught. So the slope is the rise over the run. And once we have this, we know the equation of the line. So the equation of the line of slope m passing through y naught is just multiply both sides by x minus x naught. So y minus y naught, the rise is proportional to the run, x minus x naught, and it's actually the slope times the run. So to check whether a given point x comma y actually lies on the line, we just have to check whether this equation is satisfied. Let me give some numeric example, just to have something concrete in mind. Example, let's describe the equation of this line. I see that it goes through the point 1, 3, so equation of a line through 1, 3 is slope. Let's estimate the slope here. So I see another point here like this, and a point like this. The slope being the rise over run. Here's the rise. I went 2 units up, and I went probably 1 unit to the right. So the slope is 2. And the equation, well, just use this formula or this thing. The rise is the slope times the run. So the rise is from this point is y minus 3. The run, how many units you step to the right, is x minus 1. And we know that the rise must be the slope times the run. So that's the equation of the line. If you want to check whether a given point x comma y is on the line, check whether this holds. So in fact, the new idea of Descartes in 16th century, which ancient Greeks did not know, was this idea, that actually equations, something like this, a relation between x and y. Once you know x, you can find what is y, or once you know y, you can try to find what is x. An equation is actually the same as geometric shape in a plane. There is basically no difference. You can go back and forth. Given an equation, you can draw a shape, in this case a line. Given a shape, you can write an equation. So what Descartes did was connect kind of algebra here, equations, theory of equations, with simple geometry. Well, sometimes simple, sometimes not very simple, but with geometry, theory of shapes. Okay, so this was a review of last lecture. So any questions about this? All right, so let's talk a little bit more about different equations of area lines. In this equation, we are basically given the slope and the point on the line. So we know that if we have a point and kind of direction, which means how steep we should go along this line, then we can find the line. Well, another initial question, suppose I give you 2 points. What is the line that passes through these 2 points? How to write its equation? So let's discuss equation of a line through 2 points. And let me give you names. x0, y0, first point, and x1, y1, another point. So now I'm given 2 points in the plane, x0, y0, another point, x1, y1. And the question is, what is the equation of this line? Maybe any ideas? Yeah.
So you can find out the slope first, which is y minus y naught or 4x minus x naught. And once you got the slope, you can take any one of the points and use the equation of y.
Okay, yeah. Indeed, really great idea. So we already know how to write an equation for a line if we know the slope and the point. Well, we do know the point, so we have to find out the slope. Well, for the slope, we can find out the slope from these 2 points. We know that the slope is the rise over the run. So we'll compute this rise, we'll compute this run, find out what the slope is. So let's compute the slope. In this case, it is, so the rise is y1 minus y0, the run is x1 minus x0. The slope is the quotient, y1 minus y0 divided by x1 minus x0. And the equation, well, now I know the slope, and I know the point of this line. I can use whatever of the 2 points. Yeah.
Can you have, can you flip it around and have like
y0 minus y1 divided by x0 minus x1? Yes. So it doesn't matter in what order you choose the 2 points, the quotient is going to be the same. So if you look at this expression and you think flipping this thing and flipping this thing simultaneously, you'll introduce the minus sign both in numerator and denominator, and it will cancel out. So the slope is still the same. So the question was whether the order of the 2 points matters, which one you think of first and which one is second. Well, it doesn't. The slope is still going to be the same. So now back to the equation. So we have the equation y minus y0 is m times x minus x0. Or if you plug in what m is, what the slope is, the full equation is like this. So let's actually check that the 2 points x0, y0, and x1, y1 do lie on this line. What does it mean for them to lie on this line? It means that if I plug in instead of x, let's say x0, and instead of y, y0, the equation is satisfied. Well, is it? When x is equal to x0, this thing is 0. And y minus y0, if y is y0, is also 0. So x0, y0 is on this line. And what if I plug in x1 instead of x and y1 instead of y? Is this equation true? Well, yes. x1 minus x0 will get cancelled with x1 minus x0. And you'll have y1 minus y0 on the right hand side, and also y1 minus y0 on the left hand side. So the points that we tried, well, if we wanted the line to pass through these 2 points, they are on this line. Okay, so let's have once again a short example for the equation of line some points, maybe 8 points, maybe some pair of numbers. 6,7 and another pair of numbers.
2, 3.
230. Okay, so I don't even have to draw this line to find its equation. I basically have a procedure. First, I find the slope. The slope is, I subtract the y coordinates, 30 minus 7, and divide by the difference of the x coordinates, 2 minus 6. It is important once you have chosen the order that I say think of this point as the first one, and this is the second one, to remember to subtract the coordinates in that order. If I subtract this from that, I'll have to subtract this from that. Okay, so the quotient is 23 over 4 with a negative sign because of this 2 minus 6 being minus 4. And equation y minus 7 is minus 23 over 4 divided by x minus 6. So without drawing a picture, we actually, well, know quite a bit about this line. We know that its slope is minus 23 over 4. For every step to the right, we'll make 23 over 4, which is almost 6 steps down. So it points in this direction. It's going down and pretty quickly. And we have a way to check whether any point lies on this line. If you tell me another pair of numbers, I'll plug it in here and check whether this point lies on this line or not. Okay, so maybe any questions about equations of lines? So we talked about an equation of a line under different circumstances, a point plus a slope or 2 points. Now let's talk about not just one line, but 2 lines. There are mutual positions of 2 lines which are especially interesting. One is parallel lines. So from geometry we know that some lines point in the same direction, or if you continue them all the way to infinity, like in the whole plane, they just never intersect. They face the same direction. And we call such a pair of lines parallel lines. Well, that's an intuitive, simple geometrical notion. Basically, it's just one line which was shifted to a different place. Well, now we have a dictionary. Once you have some geometric notion, like a line, we can find the corresponding algebraic notion, like an equation like this, a linear equation. Well, here we have a geometric notion, 2 parallel lines. What is on the algebraic side? Well, parallel lines have the same direction. It means if you compute the slope, which is, well, 1 unit to the right, m units up for this line, or you do the same for that line, 1 unit to the right, some number of units up. Well, what can you say about this number? Same, yes. These 2 lines are just the same line but shifted. So this picture is just the same as this picture, just shifted. So the slopes are the same. So that's the insight. On the geometric side, we have the notion of lines which are parallel. On the algebraic side, on the side of equations, we have the notion of 2 equations with the same slope. Basically, couple of exercises about this. One kind of exercise is just check are the two lines y equal to 2x plus 1 and let's say 2y minus 4x is equal to 7 parallel. So we are not given the lines as pictures, we are given them as equations. One is an equation of this form, y is 2x plus 1. Another one is a little bit more complicated equation, 2y minus 4x is equal to 7. Well, we know what we have to check. If I want to check whether the two lines are parallel, I have to check whether the slopes are the same. So I go to my equations and solution slope of y equal to 2x plus 1 is, oh, what is the slope? 2, yes. So I know that in the equation of a line, where was it? So in the equation of the line was y minus y naught is m times x minus x naught. This m appears as a coefficient of x. So whatever x is multiplied by in the equation of the form y is something times x plus something else is the slope. So here the slope is 2. I can write this equation if you want to have this equation in exactly this form. You can write that this is y minus 0 is equal to 2 times x plus 1 half. If you or I can rewrite it in a different way. So, or y minus 1 is equal to 2 times x minus 0. So if you want to write this equation exactly in this form, as y minus y naught is equal to number times x minus x naught, here are two different ways to do it. We get two different points, but of course the same slope. So this is Riemann. Our equations for y minus y naught is the slope times x minus x naught. Well, what about the second equation? It's a little bit more complicated. We have the equation written as so slope of 2y minus 4x 7. So if I want to read the slope from this equation, it's not written in this form here. Almost, but not quite. So in this equation, I have y minus y naught on one side without any multiple, and something times x minus x naught on the other side. The problem here, well, first of all, x and y appear on the same side, which is not good for this form. But that's easy to repair. So let me move the x to that side, to the right. So we write this as 2y equals to 4x plus 7. So I move the 4x to the right. The sign changes, used to be minus, now it's plus. Here's the same equation in a form which is a little bit closer. Now the x is on one side, y is on the other side. Still, we are not done. To write this equation in this form, we'll have to write 1 times y, not 2 times y here. So So we have to divide both sides by this coefficient, by 2. Or y is 2x plus 7. So now I divided both sides by 2. Now it is in this form. If you want to make it exactly in this form, maybe rewrite it as y minus 7 over 2 being 2 times x minus 1. So now we have the point and the slope is 2. The slopes are the same. Both slopes are equal to 2. So the lines are parallel. Okay, so maybe questions about this exercise. Yeah.
It's a question about this exercise, but like, do you have a preference as to which format we use? Like, we just use live programs to be off the start.
It's okay, yes. So we'll talk about this standard equation of y equals mx plus d in a second. But for now, I just okay, other questions? It is in fact somewhat remarkable that we are talking about geometry without actually drawing anything, without even imagining anything. So we have these two lines. Well, I don't see the lines. I don't really know how they are positioned in the plane. I can try to sketch them. We'll solve a couple of sketching exercises in a second. But right here we made a correct geometric reasoning without drawing any picture, by just working on the algebra side. So that's the power that this insight of using coordinates provides. Exercise about this notion of parallel lines is find an equation of the line, of the line, of the line, passing through 1,2, having both and parallel to, say, y is equal to 3x plus 7. So now I give you a line y is equal to 3x plus 7. I give you a point, 1,2, and I ask you to find the equation of the line through this point, which is parallel to the given one. So, any ideas? Yeah.
You know from the equation of the parallel line that the slope is 3. So
Okay, yeah.
You
So
can
first of all, the slope. So slope of y equals 3x plus 7 is 3. I see that this equation isn't the correct form. It's, well, I can rewrite it as y minus 7 is 3 times x minus 0. So the slope is 3. Now I know the slope of this line. I know that I want to find a line with the same slope. I want to find a parallel line. So equation of line of slope 3 through one comma 2 is, and here's the equation, y minus 2, the difference in y's, the rise is the slope times the run, the difference in x is x minus 1. So basically, we have just one new idea here. Is the idea is parallel lines are just lines with the same slope. Okay, so questions about parallel lines? So let me talk briefly about standard form of an equation of the line. So when you write this equation of the line in this form, there is a small problem. You're using, well, slope, which is a geometric notion. When you have a line, you know what the slope is, how steep the line is. The other thing that you're using here is a point on this line. And a point on the line, well, there is no unique choice. You can choose one point, you can choose another point on this line. The choices are equal. So instead of doing this, on the algebra side, we can basically open all the brackets. So instead of writing this equation in this form, so we write, we'll start with an example. Here we have an equation, y minus 2 is 3 times x minus 1, which describes a line of slope 3 passing through point 1, 2. Open the brackets as, first of all, y is equal to 3x minus 3 and plus 2. So I bring the 2 to the right and I open the brackets here. So 3x minus 3 is this thing and the plus 2 comes from here. Or y is equal to 3x minus 1. Well, the thing is, we can always open all the brackets in any equation of the line like this. So we can write equation of any line as y is equal to some number times x plus some other number. We usually give these numbers names of m and b, so we write the equation in form of y is mx plus b. And let's give an interpretation of these numbers. So m is of course the slope. What is this b? Yeah. Y-intercept. So when x is equal to 0, y is equal to b. So if you want to understand how this line looks like, here's how it looks like. X, y. It's a line of slope m. And v is just the y coordinate when x is equal to 0. So v is the y-intercept. In other words, you can say that this line is in fact a line of this form. Y minus v is m times x minus 0. So when x is equal to 0, y is equal to b. It passes through the point 0, b. This point, 0, and it has slope m. But vice versa, I can write any line in this form, and in fact uniquely. Any line has only one y-intercept, and it has its slope. So the advantage of this form is that it does not depend on any choices. Once you have a line, you can write only one equation of this form, this line. And it's also useful for sketching. Let's say I want to sketch one of these lines. Let's say, example, bring the equation x minus 4y is equal to 8, which line with this equation. Well, now we know what to do. We want to bring y to one side, x to the other side. We want to make the coefficient of y equal to 1. And then we have these ideas of slope and the y-intercept. So first of all, let's take this equation 2x minus 4y is equal to 8. Let's move y to one side, x to the other side. Let's say let me leave y on the left side and move x to the right side. So minus 4y. 2x goes with the opposite sign to the right, so minus 2x plus 8. Now, I don't want either the minus sign, neither the minus sign nor the 4. So let me first multiply by minus 1 to make this positive, and then divide by 4. And now I have the equation in the form m times x, y is m times x plus b. Sketch. Well, quite easy. When x is equal to 0, y is negative 2. So I draw the point 0, negative 2 with y-intercept, and the slope is 1/2. For 1 unit, 1 step to the right, I make half a step up. Maybe to make it even more precise, if I make 2 steps to the right, I'll make exactly 1 step up. And now I have the sketch of this line. Slope 1/2, and this is minus 2. Alright, so questions about the standard form. So when you are being asked to find an equation of the line, just an equation of the line, it's okay to practice such an equation. If you, well, basically, if you are given an equation in some strange form like this, and you want to work with it, say find its slope, find a point on this line, or any task like this, sketch this line, it's usually a good idea to bring it to the standard form. In standard form, you right away see what the slope is, and you see what the y-intercept is. In this form, well, not quite. Alright, so let's discuss one last thing about lines, and that's the notion of perpendicular lines. We know that, well, in real life the notion of perpendicular lines is quite important. Perpendicular means angle of 90 degrees, like the angle between myself and the floor. We have quite a lot of 90 degrees angles in real life, the ceiling and the wall. So let's talk about how this notion, this geometric notion of having two lines which form a degree of 90, which are perpendicular to each other, angle of 90 degrees, what is the translation to algebra? How can we see in equations whether two lines are perpendicular? So let me start with an example. I'll actually draw a couple of lines which are perpendicular to each other. on a graph paper. Let's say this line of slope 2. And I want to find a line which is perpendicular to this line. So what's the procedure? I have this line, I want to rotate it by 90 degrees. Right here, I see that the slope is 2. One step to the right and 2 steps up. If I want to rotate this picture, this whole picture of 1 step to the right, 2 steps up, by 90 degrees, what do I get? Well, imagine rotating this whole triangle by 90 degrees. What I'll get is 1 step up, 2 steps to the left. And then I'll connect these 2 points, and I'll get a line which is perpendicular to this. So I rotated this line by 90 degrees by doing this trick. I rotated this whole triangle by 90 degrees. So to make it more visible. Alright. Now what can I say about the slope of this new line? The slope of this line which forms an angle of 90 degrees with the first one. Well, it's quite easy. Here I made 1 step to the right, 2 steps up. Here if I make 1 step to the right, well, I see what happens. I make 1/2 of a step down. So this generalizes quite easily. If I have a line of slope m, if I make 1 step to the right, and this forces me to make m steps up, once I rotate this picture by 90 degrees, I'll have such a picture. 1 step up and m steps to the left. So what's the slope of a new line? The line which is perpendicular to the given one. So slope of a line perpendicular to the line of slope m is, well, look at the picture. I have a run of m units to the right, and I have a rise of 1 unit, but now down. So the run is m units to the right, and the rise is 1 unit down. So the rise is -1, the run is m. So here's the slope of a perpendicular line, -1/m. So in algebra, well, we have the following notion. 2 lines are perpendicular to each other if you take one of the slopes, the first slope, and the second slope, the result will be -1 divided by the first one. Okay, so we'll start next time with an exercise about this. See you on Monday.